Before Gary Powers' U-2 was shot down, work on a groundbreaking espionage plane had already started at Lockheed's Advanced Development Unit in Burbank under the storied Skunk Works. This groundbreaking aircraft had to fly farther and faster than any other aircraft before or since, while also having a smaller radar cross-section. President Eisenhower highly prized the strategic advantages of the U-2's aerial reconnaissance during these stressful Cold War times. Then, Lockheed's customer in Washington asked them to construct an airplane that cannot be shot down, and to do it quickly. According to the explanation provided in the article, Creating the Blackbird, which was published on the Lockheed Martin website, Kelly Johnson, one of the greatest aircraft designers of the 20th century, and his Skunk Works team had a history of producing impossible technologies on incredibly short, strategically crucial deadlines. Johnson, though, insisted that this new aircraft belonged in a different class than anything that had come before. Everything had to be invented. Everything, he said. He vowed that Skunk Works would complete its most difficult task to date, getting the cutting-edge, difficult, boundary-pushing aircraft into flight in under 20 months. The new aircraft was designed to fly at more than 2,000 miles per hour and was required to maintain a record-breaking speed for hours at a time, even though other aircraft of the time could do something similar, but only in brief bursts powered by afterburners. Friction with the atmosphere at such a speed produces temperatures that would melt a traditional airframe. Dealing with the heat posed several problems that seemed intractable in terms of material selection and design, with expected temperatures on the aircraft's leading edges surpassing 1,000 degrees Fahrenheit. Using titanium alloy, which offered the strength of stainless steel, a relatively low weight, and resistance to extreme temperatures, was the only way to solve these issues. However, it turned out that titanium was a very delicate material from which to construct an airplane. A lot of anger on the Skunk Works assembly line and new training sessions for Lockheed's machinists resulted from the brittle alloy's tendency to shatter when mishandled. Furthermore, the temperature outside the cockpit window would be minus 60 degrees Fahrenheit, despite the fact that friction would cause great heat to be produced at the aircraft's leading edges. Ben Rich of Skunk Works spent countless hours trying to figure out how heat could be dispersed across the entire aircraft. Then he remembered a straightforward lesson from one of his college courses. Heat is produced and absorbed by black paint. The plane was given the nickname Blackbird after being painted all black. The first flight of the original Blackbird, known as the A-12, occurred on April 30th, 1962. The SR-71, which had more fuel capacity than the A-12 and a second seat for a reconnaissance systems officer, quickly replaced the smaller, single-seat A-12. The SR-71 made its debut on December 22, 1964. The possibility that the Blackbird would be detected and shot down decreased even further as the size of the radar image was shrunk. Despite the positive initial test results, the U.S. government requested an even lower radar profile because of concerns about Soviet radar advancements. In order to prevent radar signals from bouncing off surfaces, the engines had to be shifted to a more covert mid-wing location, and a radar-absorbing component had to be incorporated into the paint. The Blackbird's full-scale replica was then raised on a pylon for radar testing at a hidden Skunk Works facility in the Nevada desert. The tests were carefully timed to avoid being observed by Soviet satellites, and the outcomes were impressive. On Soviet radar, the more than 100-foot-long Blackbird model would be seen as larger than a bird, but smaller than a person. The team had achieved a 90% reduction in radar cross-section when Air Force Major Rudolph Anderson was killed while flying a U-2 reconnaissance mission over Cuba on October 27, 1962. During the height of the Cuban Missile Crisis, there was increased pressure to put the Blackbird into service. In response, Skunk Works persevered through the numerous issues that sprang up as flight testing pushed the envelope. They did so carefully and creatively. The Blackbird broke records almost every time it flew, and on July 20, 1963, at an incredible height of 78,000 feet, it sustained a speed exceeding Mach 3. The difficulties persisted. In order to navigate while zipping through the air at 3,000 feet per second, the rules of navigation had to be revised. Highways, rivers, and urban areas as visual references for traditional flying were replaced with mountain ranges, coasts, and vast bodies of water. The Blackbird's piloting was a punishing job that required complete focus. At 85,000 feet and Mach 3, it was almost a religious experience, said Air Force Colonel Jim Watkins. Nothing had prepared me to fly that fast. My God, even now, I get goosebumps remembering. Even the finest air defense systems were hopeless against the Blackbird at that speed and altitude. The control panel's warning light turned red when anti-aircraft weapons were fired. But because surface-to-air missiles frequently miss wildly and explode miles away from their intended target, that would typically be the last the pilot would see of the attempted strike.